This is the screencast for section 6.3, example 1, anti-differentiation by parts. Alright, so last section you learned anti-differentiation by substitution, plus you know a lot of integrals just by knowing their derivatives, you know the power rule and stuff like that. But now we are going to work with the product rule in integral form. So integration by parts formula is this. If you're taking the antiderivative of two functions being multiplied together that are not related by a derivative, that's kind of how you know you're not using U substitution, they will equal one of those functions times the antiderivative of the other minus the integral of the antiderivative of that second function times the derivative of the first. So you'll see that in an example in a second, but first let's figure out how they get that. Well, let's just use the product rule of differentiation first. If I were taking the derivative of u times v, that would be u times the derivative of v plus v times the derivative of u. Now I'm going to move that over to the left side, which is really over here. So now I have u dv dx on one side of the equal sign, and then d dx of uv minus v du dx on the other side. Going to take the antiderivative of everything, or the integral of everything. The dx's cancel out here, so we have the integral of u times dv. So we have a function times another function, which we're calling the derivative of something. And I'll show you how that comes to play in a second. And then that will equal, well, by fundamental theorem of calculus, the antiderivative of the derivative of uv is just uv. And then minus and here's where that integral expression in your integration by parts formula comes from. The antiderivative of v times du, because those dx's would cancel. Alright, so let's see this integration by parts in action here. First, says evaluate the integral of x cosine of x. Now, I don't know just the antiderivative of x cosine of x. I can definitely see that there are two functions being multiplied here, and they're not related by a derivative. The derivative of cosine is sine, or negative sine, and the derivative of x is 1, so U substitution really isn't going to help me. That's a good clue that I need to use integration by parts. So, in integration by parts, your first step is to identify which one is your u and which one is your dv. Now typically you want your u to be something that when you take its derivative will diminish, will either decrease in, its exponent will decrease or it will go away, something that would make life a little bit more simple. So I'm going to call u x, and that is part that we will use in the formula, so I put a little mark next to that. Which then means that dv is cosine of x. So I put that over here. Alright, so now I need du and v. So I'm going to take the derivative of u, which is just 1, but then I'm going to solve for dx again because that's part of this problem, or solve for du actually. And then dv I'm going to take the antiderivative of to find v, and I get v equals the sine of x. So now I've got u, du, v, and dv. Now do you see what I mean here? Like if you take the derivative of u, you get 1, so that just makes it a little bit easier. But if you take the antiderivative of cosine, you get sine, which doesn't really complicate things anymore. It kind of just stays as complicated as it was before. Alright, so your formula is u times v minus the antiderivative of v times du. This is definitely something you have to have memorized. So u we called x. V we found to be sine of x. Then we have minus the antiderivative of v, which again is sine of x, and then du we found to be just dx. So this time we are solving for du, not like u substitution when we were solving for dx. Alright, so this first part just simplifies to be x sine of x, that's straightforward, minus, and I know the antiderivative of sine of x. So I have my final answer, x sine of x plus cosine of x, and then of course plus c. The now try problem number 1 says find the indefinite integral. So again, it's a very similar situation to the example. I have two functions being multiplied by each other. Neither one is related to the other by a derivative. I think I'm going to use integration by parts. One of them is going to be u, one of them is going to be dv. I'm going to take the derivative of u, so I want that to be something that would make life a little easier, would kind of go away as I take the derivative of that. So I'm going to make u x. Then dv is something I'm going to integrate, So sine of x, if I integrate sine of x, it's going to stay the same kind of complication level. So as we found before, du is going to equal dx in this case. And then dv, if I take the antiderivative, I get v equals the opposite of cosine of x. So now I just got to plug that into my formula. So u is just x. V is the opposite of cosine of x, minus the antiderivative of v again, and then times du, which is dx. So now the initial part is just the opposite of x, cosine of x, just combine that, simplify, whatever, minus, and then the antiderivative of negative cosine of x is negative sine of x, so that's actually going to be then a plus sine of x, and then of course plus c.